forward to this section because we are finally using the unit circle to evaluate trig functions. We've been spending time on memorizing the coordinates, memorizing the angles, which ones are the reference angles, and all for good reason, and you will see why. So I'm looking forward again to showing you how to use the unit circle. And in a minute, I'm going to ask you to pause the video and see how many of the coordinates you can fill out by memory, how many of the angles and degrees you can fill out, how about in radians. All of this will be useful for an eventual quiz. However, before we have you pause the video, there's one type of coordinate that I did not talk about in yesterday's video, and it has to do with the x and y axes. So if I'm talking about this point, remember, the unit circle is called the unit circle because the radius is 1 unit in every direction. So it would make some sense if we said that this coordinate would be 1, 0, because if you think about the coordinate plane, you are going 1 unit to the right. In that same light, if you're going up 1 unit, just like on the y-axis, it would be 0, +1. If we went on the negative x-axis, it would be -1, 0. And if we went down the negative y-axis, we would have 0, -1. So if you would like to find the other coordinates, maybe some of you have some of it memorized, especially probably those 45-degree angles. If you don't, feel free to draw a little 30, 60, 90 or a 60, 30, 90 triangle for reference. And I definitely want to give you some time to try this on your own. So please pause the video at this time, and I will be back with the unit circle so you can compare your answers to mine. In with you, here is the completed unit circle. So I would take a couple minutes to check to see if your degrees are correct, check to see if your radians are correct and make sure your radians are reduced. And then I would also check to see if you have any of these coordinates correct based on your 30, 60, 90 or 45, 45, 90 triangles. I will go into why I have certain things underlined in blue and green, and I will go over what I have in purple up here in a couple minutes. So let me give you a little time to look through the unit circle. Okay, so in the last video, I mentioned that it might be a good idea to memorize that the sine of 30 or the sine of pi over 6 in radians equals 1/2. Here's why I would suggest that. I'd say that the hardest coordinates to remember is if it's 1/2, √3/2 or √3/2, 1/2, and it depends on your reference angle of 30 or 60. So, notice something. If you know that the sine of 30 is 1/2, that means that you know that the y value of sine of 30 is 1/2. So that means that every time you have an angle that's a multiple of 30, like 150 is a multiple of 30, notice that the y value is still 1/2. What other multiples of 30 do we have? Well, 210 is a multiple of 30. Is there a 1/2 in the y value? Yes, there is. It's negative because of the quadrant. And here, notice it makes a little x, that the y value is 1/2 here as well, and 330 is also a multiple of 30 degrees. So if you have sine of 30 of the reference angle memorized equal 1/2, you have 4 of the quadrants, or 4 of the coordinates right off the bat. Because 30 and 60 are in a right triangle, they are technically called cofunctions. Sine and cosine are called cofunctions because 30 and 60 have to add up to 90, and that's the definition of a cofunction. And also, what's interesting is if you look at sine of 30, let's say that that would really be this side over the hypotenuse or opposite over the hypotenuse. If you look at the cosine of 60, it is the same ratio of this side over this one because your perspective has changed. So what's interesting is if you know that sine of 30 is 1/2, that also means automatically that the cofunction cosine of 60 degrees is also 1/2. And check this out. If you look at the 60, is the 1/2 in the x position like it should be because it's cosine? Yes, it is. If you look at 60, 120 is a multiple of 60. Is there a 1/2 in the x position? Yes. What else is a multiple of 60? Let's see here. Going to be 240. Is there a 1/2 in the x value? Yes, there is. And then last but not least, if we take a look at, let's just see again, let me make sure. Is 300 a multiple of 60 as well? Yes, it is. Is there a 1/2 in the x position? Yes. So if you have this memorized, you get this one for free, and so some of these coordinates will be much easier to get. So let's get into using this unit circle. So this is asking, at the angle 5 pi over 6 in radians, what is your y value? Because remember, sine really leads to y. So we'd find 5 pi over 6 on our unit circle right here. The y value at 5 pi over 6 is positive 1/2. So my answer, angle in, ratio out, is 1/2. The cosine of 5 pi over 4. First, 5 pi over 4 is right here. Cosine is really saying what x value exists at the angle 5 pi over 4. Well, the x value that exists there is negative root 2 over 2. So yet again, we plugged an angle in, got a ratio out. Cotangent time. So if we looked at finding the cotangent of 5 pi over 3, I want to remind everyone from the last video that tangent of any angle is usually the y over the x value. So it would make sense that the cotangent of any angle would be x over y. So if I looked at 5 pi over 3, which is here in the fourth quadrant, and the point that goes with it is right here, if I compared the x over the y coordinate, that would be a positive 1/2 divided by negative root 3 over 2. As we've been practicing, that really means 1/2 divided by negative root 3 over 2, or 1/2 times the reciprocal of 2 over root 3. Don't forget my negative there. The 2's would cross out, and I'd be left with negative 1 over root 3, which can be rationalized to negative root 3 all over 3. So that would be my answer, or my ratio, when I plug in 5 pi over 3 into the cotangent function. Let's do 3 more. Cosecant of 315 degrees. So now we switched from radians to degrees, but we're still using the unit circle as a basis. So 315 degrees is right here. In radians, that's 7 pi over 4. Cosecant is really the reciprocal of sine, and so sine of an angle is really related to y values. So cosecant is the reciprocal, so I'm thinking it really stands for 1 over the y value. So at 315 degrees, the y value is negative root 2 over 2. So what we're really saying is 1 over negative root 2 over 2. And again, if I simplified and rationalized, I'd have 1 divided by negative root 2 over 2, which is the same as 1 times negative 2 over root 2. Just showing all my steps. So we have negative 2 over root 2. If I multiply top and bottom by root 2, I would have negative 2 root 2 all over 2. That's a lot of 2's. Cross those out. So my answer will be negative the square root of 2. The secant of 60 degrees. Well, first, secant to me means that we are talking about x, because secant, the reciprocal function, is cosine. So I'm going to write a little note that cosine really deals with x. So that means that the secant of 60 degrees is really 1 over x. So if I look at 60 degrees, or pi over 3 as a reference, the x value there is at 1/2. So this is really 1 over 1/2, which is really 1 divided by 1/2, or 1 times 2 over 1. So my answer is just 2. last but definitely not least is good old tangent. So specifically, we're trying to find the tangent of 150 degrees. Remember that the tangent of any angle is y over x. So if I look at 150 degrees, or 5 pi over 6, we are taking the y value of 1/2, and we are dividing negative root 3 over 2. So that is 1/2 times negative, well, let me go back a step. Let me not skip steps there. So that is really 1/2 divided by negative root 3 over 2, which is the same thing as 1/2 times the reciprocal of negative 2 over root 3. Just like a previous example, the 2's cross out, but there's still a negative on top. So we have negative 1 over root 3, which reduces or rationalizes to negative root 3 all over 3. So tomorrow in class, you will be practicing this skill a lot more. We're going to make sure to give you a lot of practice here. I hope the video was helpful, showing the work for where I'm getting my final answers. Feel free to ask myself or any teacher more questions in class tomorrow if need be. Thank you for your time, guys.